Hello everyone, welcome to CivilPrep. I am Krishna Gupta. So we have a case study here, important case study from Indian perspective, that is India's greenhouse gas emissions, okay, that is GHG emissions, where we are looking at trends and challenges will be discussed here. And what are the challenges which are coming in this part? So we'll be discussing this in this particular case study here. Okay, so this is one of an important case, one of an important part uh, from the perspective of Indian geography, where we need to explain the condition of India, the situation of India with respect to the steps taken by her in the climate change part, and what it is doing for the environmental conservation and for promoting the environmental friendly products here. Okay, so we can see here one of the trend which is provided below. So here we have number one thing, that is coal, okay, which is responsible for the CO2 emissions in India. Okay, so this is by the fuel type. So after this we have oil, then we have natural gas, and then we have other type of fuels. Other type of fuels can be, it can be biomass, it can be we can say uh, it can be shale gas, or it can be any other gases or petroleum products. So majorly we see that it is the coal which is responsible for highest emissions of CO2 in India. Now, let's look into the context part here, that greenhouse gas emissions trends in India. Now we will see that uh, the emissions trend in India, it rose from 2011 to 2019. So here we see one of the trend which is provided here, the emissions trend. Okay, so before in the 2000s, it was nearly 1 billion. Okay, 1 billion of CO2 emissions. Okay, but in the 2019, we'll be seeing that, which is a part here, it is more than 2.5 billions. Okay, it is more than 2.5 billions here. Okay, so it has risen by more than 2.5 times. Now, when we'll be looking at a report from 2025 perspective, okay, 2025 trends, so it might have rose by more than 3.5 times, because the energy demand in India, it has increased steadily from 7 to 12% since 2010. So therefore, the same trend is being carried on. But what we will see here, that after 2019, the event of pandemic, that is COVID-19 pandemic, it has resulted into the decline of the fuel import in India, and this occurred by almost minus 5.5%, which was a decline here. Now, there was a recovery after the post-pandemic era, okay, which has led to the record high emissions in 2023, with 7.8% of the global greenhouse emissions, which was done by India. Okay, when we look at India, India is the fifth largest emitter of CO2 in the world. Okay, for example, we have the previous part here, like USA is there, then China is there, then we have Russia, then we have Brazil. Okay, then we have India here. Okay, not Brazil, but the EU is there. Okay, so after EU, we have India here. So India is the fifth largest emitter of greenhouse gases in the world. Now, when we look at the geographical concept in this part here, which is related to emissions. Now, emissions we can see here when we make a map of India. Okay, here we'll be seeing that there are certain regions which is consisting of various kind of fuels here. For example, Bombay for petroleum, then Krishna Godavari Basin also for petroleum and natural gas. Okay, this is for petroleum. Then this is for coal, Chota Nagpur Plateau, Meghalaya Plateau, it is for coal. Then we have Digboi in Assam, it is for petroleum. Then we have certain regions in Gujarat, okay, for petroleum and coal. Then we have the region in Tamil Nadu, it is also for coal, okay. The Gondwana region for coal, the Dharwad region for coal, then Andhra Pradesh region for coal, okay. So here we can see that in the interior part of India, we have various regions where we have the presence of coal and also the presence of petroleum and natural gas. So this is one of the factor where India is having one of the largest reserves of coal in the world, not of petroleum and natural gas. We import them right now. So this gives us one of the part, and it shows us that why is coal is one of the contributor. Why coal is one of the largest contributor for the emission of CO2 gases in India. Now, this thing we can analyze further. For example, under the physiography, the coal-rich regions like Jharkhand, Chhattisgarh contribute significantly to the CO2 emissions. Similarly, the forest cover in the Western Ghats in Northeast India, they act as a natural carbon sink. When we talk about the various forests, so under the forest part, we have Western Ghats region in India, okay, which have very high presence of trees. Then we have most of the northeastern part of India, which is also consisting of very high amount of tree cover. Then we have Madhya Pradesh, certain regions of Maharashtra, Chhattisgarh. Then we have regions of certain regions of Andhra Pradesh where the tree cover is quite high. Okay, so this also we can see here in this part. Now, next is agriculture. Agriculture will be seeing that it is one of the factor which is affecting the CO2 emissions. This is happening as in terms of excessive rainfall, which is occurring, and it is resulting into the excessive methane emissions. Now, methane emissions, it is one of an important factor because it has become second largest greenhouse gas component. Okay, when we talk about the CO2, it is almost 413 parts per million. Okay, in the contemporary time. But when we talk about uh, the methane emissions, it is almost around 1130 parts per billion. Okay, it is 1130 parts per billion. So this parts per billion, it has almost doubled in last 20 years. Okay, in last 20 years, the methane concentration in the atmosphere, it has doubled. Therefore, it has also become one of the potential greenhouse gas emitter in the world. Then there are certain anthropogenic activities which is also resulting in the increased emissions in India. For example, deforestation, very high, infrastructure development, very high, rapid urbanization, very high, industrial expansion, very high. So this is resulting into more emissions. We can also see here that we are currently into the stage of takeoff stage. Okay, we are under the takeoff stage. Basically, we are not in the takeoff stage, but we are moving towards the takeoff stage, and we can enter it anytime. So, under the Rostov's model, we will be achieving this takeoff stage, and after this takeoff stage, we will be into the stage of we can say we will be into the age. We will be moving towards the age of high consumption, high mass consumption. Okay, so this stages we will see that as we are developing. Okay, so the roster model it is also providing us that we will be continuing to develop in future also. So until this development is not achieved, we will be having rapid urbanization, rapid industrial expansion, high deforestation. Then there will be a requirement of the fuel will increase. Then demand for energy will be increasing year on year. Okay, along with that, we also have one aspect of population increase in the contemporary time. Though the total fertility rate it has declined by more than 2.0. Okay, it has come below 2.0 total fertility rate, which is below the replacement level, but still we are growing right now. Now, next part is climate change, where the extreme temperature increase demand, energy demand, that is the cooling, industrial needs. Also, erratic weather disrupts climate mitigation efforts. For example, in the previous section of monsoon variability, we have understood that how monsoon it is getting variable in India. Okay, there are several factors like Indian Ocean dipole, then there is Anso cycle. Okay, then there is Atlantic oscillation. Then there is Arctic oscillation. Okay, then we also have Madden-Julian oscillation. Okay, so all these things, they are affecting the monsoon in India. Okay, the rainfall pattern is being affected here. So this is also disrupting the climate mitigation efforts of the various organizations of the world. Now, here we see that because of temperature is increasing right now, it is resulting into the increasing demand of energy, that is for cooling, industrial needs, etc. Okay. Now, moving towards the various models and theories part, here we can see that one of an important component here, that is the climatic forcings model, which was given by one of the very important scientists, that is Milankovitch. He explained external solar radiation, volcanic activity, plate tectonics as the external part, while internal part he has seen here the ocean currents, the greenhouse gases as the climate drivers. Okay, so this is one of the very important factor. Here we'll be seeing that there is the greenhouse gas uh, addition in the atmosphere, ocean, biosphere, etc. This is basically seen as one of the component which is an internal factor resulting in or changing the climatic forces. Now, next is the Earth system model, which was also given by Bert Bolin. He integrates the atmospheric, oceanic, and terrestrial interactions in the climate change, which we have already discussed previously. Then there is limits to growth model. Here, this has been given by Meadows. Okay, very important. This is also one of the part of we can say non-communist manifesto. Okay, basically given in 1972. Okay, so this is also one of the component or part of new Malthusian or new Malthus. The new Malthus views are provided here. Now, it predicts the environmental constraints on economic expansion. Basically, limits to growth. It is a system-based model. Okay, it is having certain variables like population, then pollution, then waste generation. Okay, then we have food, then we have energy. Okay, so there are five components, five variables, and there are output in terms of if we have increasing population, then also we have increasing energy demand, we have increasing pollution, so it will result into a catastrophic state. It was called as catastrophic model. But if the population it is made more stable, then technocentric development is done, which results into the decline of pollution, decline of energy demand. So it results into the one important part, which is a sustainable development. So there is a catastrophic development and sustainable development. In mid between of this part, we have various other, we can say, the simulations which gives us various other outcomes also. But these two outcomes, they are important for us. Then there is sustainable development model, which was provided under the Brundtland Commission in 1987, which also advocates balancing an economic growth with the environmental protection. Okay, this was made very much. The picture was made very much clear in 2015. Okay, with the goals of sustainable development goals. Okay, so there are 17 goals in total. Okay, so this is also one of an important component. Then the technocentric approach given by Julian Simon, okay, very important, argues that technology can solve environmental challenges. So this is a part where the scientific determinism is seen as one of an important part, where the science can determine the problems for the human solutions or the environmental solutions. Then under the same part, we have Gyanism, okay, which is seeing the earth as a self-regulating mechanism. So how the system in the systematic manner, the feedback mechanism, it helps in earth to uh, self-regulate itself depending upon the availability of or the changes in the environment. For example, if we know that we have less amount of food and less amount of water, so we will be adapting to the conditions where we will be eating less food and consuming less water for certain day or certain period, so that the things are quite well managed. So the same thing is provided here. Then there is a IPAT model. Okay, IPAT is basically I equal to PAT. I is for impact on environment. P is for population. A is for affluence. And T is for technology. Okay, that is population, affluence, and technology. For example, USA will be seeing here that USA just have a population of around 22 crores. India, we have population of 145 crores right now. Okay, but we will see that the affluence in USA by the 22 crore population, it is very, very high. And in India by the 145 crores, it is very, very low. The technological development in USA, it is very, very high. While the technological development in India, it is very, very low. So when we compare two contrasting countries, that is developing country and developed country, USA, India, so we see here that the impact which is made by both the countries. So when we assess it on the basis of the population part, the affluence part, and the technological part, we are able to see that which country is doing more damage to the environment. Okay, so here we can assess this part. So we can see here that the overall emission by the USA, it is almost 12%. The overall emission by India, it is 7.8% in the contemporary time. So it is USA is doing more damage in the contemporary time. But yes, with the rising population in India, it is also seeing a growth in income. Okay, so there is also growth in affluence. The growth is technology is also seen here. So with respect to all these things, India will become one of the largest emitter or one of the largest country which will be doing damages to the environment in future. Okay, so this is explained well in the IPAT model. Okay, now next is active and passive carbon pool model, which is given by William Schlesinger. Okay, so it differentiates between the fast and slow carbon storage. For example, if certain carbon is present in atmosphere, so this carbon, it will be moving to the soil, it will be moving to the plants, it will be moving to it will be taking up heat and it will be acting as one of the component which will be hitting the atmosphere, or it will be resulting into the global warming. Okay, so it is active in the warming part here. Therefore, it is becoming one of the component for the active pool. While when we talk about the passive pool here will be seen that it is the carbon which is present in fossil, okay, or it can also be present in trees, etc. So here it is not contributing for the greenhouse gas. Okay, it is not contributing for the global warming. Therefore, this is acting as a passive pool. Okay, so this also explains that what are the conditions in India, okay, how much coal is being extracted, how much petroleum is being used, and how it is resulting into the emission of greenhouse gases in India. Then there is a carrying capacity model which was provided by Thomas Malthus. Okay, so it defines the population limits based on the resource availability. So here we have the limits which are provided here. It is based on two mechanisms. One is the positive check, and second is negative check. Okay, positive check, for example, if there is any kind of we can say catastrophic event which results into the decline of population. Okay, so it is one part which is actually restricting the population, while in the second part, the negative check, we see that there are various pandemics are there. Okay, then there is certain parts, certain diseases which results into the loss of life. So it is becoming the second part for the limit on the population. Okay. Now, moving further, certain theories are there. So under the theories part, we have environmental Kuznets curve. Okay. So this was provided by Simon Kuntz. So here he specifies the emission rise with the development before the stabilizing. Okay. So when there is there are certain stages. Okay, there are certain stages of development. For example, there are three stages. So as the development occurs, we will see here, this results from stage 1 to stage 2 and to stage 3. But as the development occurs, it results into the more income, more technology. Okay, so various conditions which makes the country better. So therefore, in this condition also, there is the emission rises, okay, during the development stage. But after a country, it achieves a certain level of development, it becomes more stable. And here, after this part, there is decline of emission of these greenhouse gases occurs. Okay, so this is provided by environmental Kuznets curve. Now, next is climate change theory, which is provided by Swante, okay, which links CO2 emissions to the global warming. Then there is resilience theory, which is provided by Holling, which examines adaptation to climate stressors. Now, various laws will be seen. First is the Engels law, okay, where the income influences consumption, affecting disaster preparedness. Okay. Then next is Zipf's law. Okay, Zipf's law, we will see that, which explains the population distribution, which is affecting disaster. Not disaster part here, but it is the CO2 or greenhouse gases emission. Okay, then we have law of social change of Auguste Comte, which is also revolving around the societies, which is evolving as environmental challenges, reshaping the structural part here. Then when we look about the perspectives, we have first economic perspective with respect to Amartya Sen. That is, there is various disruption of economic part, the livelihood, which is happening because of the uh, greenhouse gases emission and global warming. Okay. Similarly, we'll be seeing that there is a sociological perspective which is provided by Durkheim, where the community cohesion, which is aiding in the part of the global warming and the greenhouse gas emissions. Okay. Then there is Robert Putnam, who has given the political perspective. Okay, he is also quite responsible for the behavioral part here. So the trust in governance, which influences the part of the CO2 emission and the greenhouse gases. For example, USA opted out of Paris Agreement, but the various other countries, developing countries, they are supporting the Paris Agreement. So here the trust in governance is also one of the part which is needed to be considered. Then developmental perspective, sustainable infrastructure is quite important here, okay, which is also quite important on the global warming plus greenhouse gases emission. Okay. Then next we have strategies for reduction of uh, the reduction of emissions here. First is the Nicholas Stern, who advocates carbon pricing and green investments. Then Eleanor Ostrom, supporting community-led climate governance. Then Amartya Sen calls for equitable climate policies. Then Gilbert White, emphasizing disaster preparedness for the climate resilience, very important here. Then Paul Hawken proposes regenerative economic models for the sustainability. For example, there is a cyclic model, okay, which is helping in us to recycle the various waste, okay, waste recycle, then economic, uh, we can see here the electronic items, then plastic recycle. So recycling a lot of things are important for us to understand or help us to reduce the emissions in future. Okay, so guys, this was one of the topic which is quite important from the perspective of geography optional, where we are able to look at the emissions trends and various challenges which are seen in India, and we can see certain solutions which are seen from the theoretical perspective by the various thinkers in this part. Okay, so guys, this is one of the case study. If you want to write answers, okay, you want to discuss live answer, so you can join our Mentor Quest 500 program, where we'll be writing 500 questions in a live manner. Means will be online. Okay, you'll be writing answer. I'll be seeing them. Okay, I'll be checking them, and we will be discussing the answer in a live manner, like we are talking to each other. So this will be done here, okay? And there is another case study program where you will be looking at the case studies and we'll be discussing the cases which are present in the contemporary time. These cases will be taken from various magazine and sources, okay? There are more than 10 sources, and these 10 sources, they are very verified sources from where the cases have been used in the UPSC examination for geography optional. So guys, see you in the next topic. Take care and see you in the next class. Bye.